Today, I want to share with you in just yet another way to look at architecture and software. How do you build it? What matters and what doesn't. So I'll start with a quick story. A few years ago, my friends and I went to Vancouver Island, to a beautiful lake, and we spent a few days enjoying ourselves on that lake. And the house that we rented came with actually 2 canoes, a boat like this. And obviously enough, on the second day, we decided to venture out in the lake and figure it out. And obviously, after 10 or 20 minutes, we were in the middle of the lake somehow, and we had a problem. We tried to paddle, and we tried to get back home before it gets dark. And the problem that we had is we didn't really know how to operate a canoe. As you can see, the paddle that you have with the canoe, it kind of works on one side. You can't really go like this and sort of balance it out. You really have to figure out a way to go in a straight line. So we started with the most natural choice. We started doing independent work and trying to figure out what I personally should do to contribute to going forward. And the end result of that was we were spinning in circles and not going anywhere, trying to figure out individually. So we're like, okay, that's not working at all. So we thought, we were both in software business, so we were like, let's try to apply some of the experiences that we had to this. So we decided to go for a leadership kind of model where one person would basically give all the commands, left, right, left, right, left, right, stop, stop, faster, faster. Well, that was a little bit better. Marginally, it was better. We were getting closer, but it also was getting darker and darker. So we're like, we're freaking out. It's a big lake. Like, how do we get back? So the next idea that we had was a sort of a steering agreement. So we agreed that one person always paddles on the left, the other person always paddles on the right. And if you see that the canoe is turning to the left side or to the right side, just stop paddling for a little while. And the other person, being on the other side, will just compensate for that movement very quickly. And you don't need any synchronization whatsoever to get any results. And actually, we got back home, safe and sound before it got dark. That was really the solution that we were looking for. And I started thinking about this, like what was the core of this experience? And I think the core of this experience is really similar to what we have in software development. It's about communication. Building software is about establishing communication lines and figuring out how to communicate with each other, across teams, with customers, with other stakeholders, to figure out what should we do, how should it work, how do we actually ship it. So there are different models that we can apply in software. And you've probably seen all of these kind of models with regards to software development, including those that I've just described in the boat case. So you probably saw cases where developers individually go on and develop whatever they think is right. And the end result, the product overall, just doesn't work. It's spinning in circles. And a more common model, obviously, is to have management. So you would have people that have their limited perception of the reality from where they are and what they do, and they give commands to everybody, do this, do that, do this, do that. And yeah, it works a little bit better, but still, because of that limited perspective, because there's very little feedback loop or it's delayed, you can't really deliver swift results. So I was thinking, how can we apply the idea that helped us with the boat to software? And the idea was this: how about we react to observations? So just like in a boat, you would react to the fact that you see the boat is being oversteered, and you just wait a little bit. What if we can apply this somehow, the same idea, in software development? And I was thinking, what do we actually observe when our system is interacting with customers or working with other external systems? And what happens is you don't really observe pieces of data flowing through, between them. You don't see domain models being transferred. What you actually see is requests for certain changes in your system, adding something, deleting something, shipping something. And in effect, as a response to those requests, you see results of that. So basically, we modify our databases to reflect the change in our domain in order to maintain that reality that we need to show to the users. So since we actually observed that, why can't we build just a system around this fact? Because it's hard to argue about facts. It's easy, to start arguing about domain models and bounded contexts, for example, and start figuring out what does this mean. Like, we would have a word for something, say a user or a person or a purchase. There are many concepts, and they're all generalizations. They're all abstractions. So it's very hard to argue about what should go in them, how should they behave. And that means you have to have some sort of agreement on what they are, how they function, what do they contain. If you don't have that agreement, your databases cannot essentially exist because people are looking for different things in the same entity. So that means you have to have this sort of architect role or somebody or a committee of a kind or a procedure of a kind that allows you to maintain that consistent view. But if you just record and process the events that come at you, the domain changes, if that becomes your source of truth, then because you can't really argue about them because they already exist, they already have happened, you can base your domain model on that. And obviously, this is a known concept. A lot of people already learned about it. It's called event sourcing. So basically, for those who don't know what event sourcing is, in a nutshell, it's very simple. Basically, the events as statements of fact, so basically something that has happened, those are the source of truth for your data in the system. So what you do is you process all those events and apply them to your database, basically your state, to reflect that change in the domain, and so that you can show it, and react to it appropriately. For example, if a user changes his name, instead of going to a database, looking up the user, and modifying the field, you would rather have an event called name changed. And that event can be applied to a database, for example, and you change the state of that user, but you still retain this whole lineage of events that leads to the change, so you can actually see what's happening. And the way it usually works is it's like a left fold. So your database is your state, and you just apply more events that are coming in, apply them to the state, and you see that as sort of aggregation of what happened as the state. But there's a little bit of a problem there. What happens, for example, if we decided tomorrow that our domain model isn't adequate anymore? We need more information in it, less information in it, something like this. Or we discovered a mistake in it. Basically, what we need to do, we need to replay all the events from a certain point in time, and sometimes even from the beginning or from a certain snapshot, in order to get the right database. Or what if you have an event that was actually timestamped in the past, meaning that change didn't just happen. It happened some time ago. You had a disconnected system or any kind of other unreliable networking situation. How do you really do this? Well, you have to go back again and replay it from the beginning. So in theory, that sounds fine. I mean, it's not very difficult. It's kind of deterministic process, so what's not to like about it? In the reality, though, there are many questions. For example, what do we serve to our users while we're rebuilding the database? It might take quite a while. There's a lot of data, there are a lot of events. Because the users will make decisions based on what they see. If what they see is actually incorrect, how do you reconcile this later? Or do you have to stop and basically let users wait for your process, even if it takes like a couple of hours, to basically reprocess all of your data? That's problematic. So obviously something is not great about it. So here's another story of mine. Just a few months ago, on a rainy night in Bangkok, I went to an event called Hack Night, and I was just overhearing a conversation where one person was describing the benefits of functional programming to somebody else. And I kind of felt funny about this because I've been doing functional programming for quite a while, for at least a decade. But recently I have jumped ships probably a year or two ago from Erlang to Java. And I was feeling kind of bad about it because I do understand the benefits of functional programming. And you know, when you overhear things like this, you're sort of questioning yourself, should I have actually changed the ships, and why did I do this? And obviously, I knew all the standard arguments for that, such as tooling, ecosystem size, community, et cetera, et cetera, et cetera. There are many reasons, everybody knows them, at least around the functional communities. But I felt there's something more to it. There's something that affected my choice in a way that I didn't quite recognize when I was making the change. So it was sort of a subconscious change. And I started thinking about the databases and data management. I've been mildly obsessed with databases for probably over a decade as well. I've built some funny things, like I tried to experiment with blending the frame databases and integrated databases like MUMPs. Or a few years ago, I've built a simplified hybrid of event sourcing and Redis for a particular case in gaming. And I was thinking about how do I reconcile the events that happen during the work with this database. And I thought if we decouple certain things in our architecture, it would be interesting to see how it works out. So oftentimes, when you hear the word event in programming, it follows with handler, like event handler. It's almost like it's one word. And it's kind of natural because of all the APIs and sort of like contracts that we have that events have to be handled. Events, if you don't handle them, they disappear. They're just temporary things. But I think the problem here is that we kind of conflated events and messages in one term. So message is something being sent from point A to point B, and event is basically a category, just a category of data. Yeah, it can become a message. You can send it somewhere, but those are not the same thing. And when you start thinking about the event as a category, interesting thing can happen. So in classic event sourcing, this is roughly simplified model of what it becomes. So you have an event journal, and you have a database in front where you apply the state to. Basically, it is your state, and you apply events to it, and you get your updated state. But how do you search for data when you're writing an actual application? Most of the time, you don't actually scan the tables. That's not very efficient. So you would have indices created either for you, or you have to manually, explicitly define indices. But then what you end up having is a database, your storage sort of, that actually imposes a certain domain model onto you. So it says, well, a person should look like this, product should look like that, and that's about it. And everybody has to synchronize on those decisions, whether they like them or not. But then I thought, well, since we do have the data in the events, what if we just throw out the database and index events directly? So the data in actual events, what will happen because of that? Well, the first outcome of this is that your database is actually becoming functional, because the main function that you would have is a function on an event that produces new indices. It doesn't actually modify anything. It's just, here are the new indices. We can just write them down into the, into the whole index. And this way, we actually know that we're not modifying anything. And this led me to an understanding and to a thought rather even that when you think about it, when we write programs in using nicer, more interesting, more clean concepts such as functional programming, most of the times we end up putting them into an environment with traditional databases like PostgreSQL or some KV storage, something like that. And then for most of applications, like line of business type of applications, the algorithms in those components that you write in your language of choice are not very complicated. But every time you hit the disk, so you either have to write to the database or you have to read from the database, your components are essentially getting dwarfed by the very mutable state of your database. You don't really know when somebody is going to write to what you're reading, so you don't really have a chance at arguing about the behavior of that system. So my realization was that functional systems, or systems that are easier to argue about, are actually more important than the language and the principles that you employ in individual components. Because if you don't apply those principles at large for the system, you don't get the benefits that are typically associated with that. And that was actually the main reason why the change from the functional approach for me in terms of actual programming was not as important, because what I needed to focus on is actually building functional systems, and so that I can argue about them. So to give you an example, we just talked a little bit about indices, but what does it actually look like? Let's imagine we have an event called customer picked an item. Browsing the website, they basically put something in the basket, right? So they picked an item, there's a reference to the customer, there's an item quantity, all the standard things. And we index pretty much on everything, so we can quickly find events of that kind. So how do we figure out what does customer have in their basket? So, since we don't have a table for a basket, right? We don't have sort of an encapsulating model there at all. What we do is we query for these events that have a certain customer ID that we're working with, and the ID of this event has not been indexed in another event called customer checked out. That's particular item. So we know they put it in, but they haven't checked it out. So it's in the basket. And basically that means that we can build domain models, not as tables or sort of aggregates of key value pairs, but we can actually build domain models as sets of index queries. Basically, let's say if we were using Java, that would be a class that has a couple of methods where every method is querying particular limited set of indices to retrieve a local understanding of what we are working with through the events. And that means that your models are actually runtime, they're not serialized to the disk in any way. And what that means is two things. One is making changes in your domain is inexpensive. Basically, if tomorrow you figure out, well, this is how it should have looked like, you only change a few lines of code querying for stuff, and you never have to migrate the database. No downtime there. No need to figure out like how do we move this data from here to there. It's still the same data because, well, the past is the past. It doesn't really change. And what's even more interesting, and we're getting closer to the communication problem here, is that it allows for the plurality of domain models. So let's say you're working in a bigger team, and you're working with customers, and they have accounts of some sort, and you're the one responsible for building a UI. And you want to show the customer's name in the dashboard so that they know they're logged in, right? So do you really care about all the, yep?
Oh yeah, when you say that you'll never have to do a database migration, are you implying that event schema has never changed?
So events schemas don't change in a way that any moment you actually change the event layout, you don't really change the old layout, it still stays there. And the new layout is basically the new event. It might have the same name, but it's a new event. Basically, old stuff can be migrated if you want, but they still represent the very same thing. Does that make sense? Or not yet?
That makes sense. I feel like it's presuming that you don't have like SQL level restrictions on your data types, right? If you were to change like a key in the event definition,
right.
You still would have, I feel like, a migration to contend with.
Well, basically here, migrations are more like a rewrite of the data to a bigger format, if it's possible at all. So an interesting thing here is that you don't necessarily need to migrate events. If your changes are fairly limited, so you only like change it once or twice in that particular piece, right? You don't actually have to migrate because you can just incorporate the old model for the events and the new one in the same query. So you can build part of your state from the old data, part of it from the new data. When migration is difficult to do, right? It's better to avoid that, because it builds up and your queries become bigger and more slow. But it's possible. For at least as a temporary measure, when it's a difficult process to migrate them, you can quickly have like sort of a join of two queries to retrieve the composition of both. So this way you actually don't have to suffer through the migration. But most of the time, at least in my practice, what I saw, migrating events is not difficult because basically what usually happens is you add more data to the events. Basically, you expand the scope of the event. In cases when you lose some of the data, you still can do the migration because you can still keep the older events. So that data still doesn't disappear, but you can have the new version of the event with some data lost. You decided that some data is not very interesting to you at all, right? So you can still migrate and you can still keep the old versions. You can even offload them, to a different sort of data at rest system, and just don't care about the data for at least a while. Does it make sense?
Yeah.
All right. So going back to plurality. So I was talking about having one case where you develop front end and basically you need to render person's name on the dashboard. So you only care about the last time the user or the person rather changed their name on the account. So instead of going a classic way where you process all the events just to come to a conclusion that, well, this is the person's name now, you can basically query the database for the latest name changed event for that particular person, because that's what's good enough for you because you don't need any other information. But if you have somebody else working on, say, sort of fraud prevention component, they actually do want to know all the names that were associated with the person so that they can actually do cross references with some other data, so they can build their own models where they can see what were the names of that person throughout the whole history of the operation. And see, this way you don't have to argue with that person, like, do we have to have one single model that describes this is a person, especially if we have somewhat shared code base, right? And I created, say, a person class. Then I go to you as a fraud prevention developer and say, well, you have to use that class, right? Because otherwise we'll have two classes, and they also map onto our relational database. So it's a mess, and they have to figure out a set of compromises. How do we handle this? Where do we store data? They possibly have to duplicate some data because I want my own user's database. He wants another database for, say, suspects of fraudulent activity. So we can just have both views at the same time based on the same data, but we're looking at it differently. And if you think about it, when we talk about building systems, we often talk about, well, we need to see the state of the world. But is there actually a single state of the world? If we think about ourselves, humans, Do we actually perceive the world, the same way, the next person? No, we perceive it differently. We also don't perceive it consistently either. It depends on the context and depends on intentions. Just about everything, affects the way you see the world, and it's always just a piece of the world that you see. You don't observe the entire world. That's just an impossibility. Just you're briefly peeking into the world and seeing what's happening there. Why can't programs do that? Well, they can, because they can actually query for what is interesting to them, what is serving their purpose, and nothing more. So an interesting example of applying this principle, back to the Earth. Yeah, question there.
Are you suggesting something like we can have one gigantic database and everybody can post their view on it, and therefore we can have an account database with 200 columns, no problem? Because I'm looking at my snapshot of the view, and you're looking at my snapshot.
Right. So the question was, am I applying a sort of like a big, gigantic database where like all the data is, and we're defining our sort of individual views on that? Am I correct? Yeah. So in a way, at least at the conceptual level, yes. Like I imagine it as a sort of sea of facts, basically things that have happened, and we can sort of pick out what's interesting to us and build our sort of limited contexts and retrieve the data that is of interest to us right now. So that means we can basically go into other domains that we previously might not have considered. And retrieve data, sort of from other subsystems, something that was not directly related, if it helps solving the problems at hand. And on the technical side, though, it might obviously be not a single database, but you might have like a routing technique that would allow you to pick events from different places. Does that answer your question?
Probably for a short-term period of time, I can see that this is being very helpful.
Uh-huh.
But view change over time, department change over time. Your point of view may get lost as you move on to the next project, and therefore people will lose track of your view. And over time, data just getting chunkier and chunkier, and no one really know how within a single entity, you don't really know how those two relate to each other. All you know is what's relevant to you right now. So I'm just thinking that maybe there is a situation that as this, if we are practicing this particular pattern for a long period of time, I'm thinking that there is a possibility of getting some messy situation that, especially at the database level, is kind of.
Great question. So I'll try to compress it a little bit. The question is, do I see whether over longer periods of time, whether the database gets messier because like there's a lot of views and onto how people can see data, and some of the context and the views that people might have used might have gotten lost over time. Teams change, objectives change. So basically, you have to see it this way. The database itself, it only stores events, so something that has happened. We're never modifying the events themselves. And the views are really just pieces of code. So if you retire a piece of code or never execute it, you never query for that particular configuration of data. And you can even do some analytics type of stuff. So for example, if you track which indices you use, for example, nobody's searching for, say, name changed anymore. You can actually analyze, okay, why is it there? Like, why is it still being indexed and nobody's using it? Maybe like it's time to retire that index, right? Because, well, we can rebuild it later if it's necessary again, right? The data is still there. But we can see sort of in a sort of a reflective way how we're using the system because the views are not really serialized, because they're just pieces of code. So your code becomes the domain model in itself, and you don't really put anything into the database. The only thing that we amend the events with is the indices, and we can track their usage. Therefore, we can tell what's being used and what's not. Okay, one more question.
So with the query that you had up before, it's like you were creating a shopping cart in its current state, but there were IDs related to product, right? So in the database, from what you're saying, it sounds like on one hand you're saying that only events exist in the database, but on the other hand there's a product ID. So I'm a little confused, like is there a product entity or not?
Sure. Let me repeat the question. So the question was, there was a little bit of confusion about the example that I gave for the query, where I would build this sort of runtime representation of the shopping cart, and there were references to things like product ID, and that was a confusing moment because what is a product ID in a fully event sort system, correct? So basically, it's a very valid question. So basically, what I usually do, it's basically I need to refer to something always. There's always some concept that you need to refer to if you want to link to something. So I usually use two approaches. So one approach is I announce some sort of entity by having an event. Basically, when something comes into existence by being referenced sort of from the real world for the first time, that event, the creation event of a sort, right, becomes the ID of that event becomes the ID of the concept, right? So if we're talking about products, like for example, we just stocked some product, right? Like for the first time, basically the introduction of the product to the line of products. That event or that event's ID, in effect, will become the ID of that. It's just a convention, really. Like you can invent other conventions. I actually have another convention that I also use sometimes, is sort of a funnier way to refer to things. So basically, when you have concepts that have multiple attributes related to them and they build up over time, like a person, for example, you can have many attributes about a person. So what I do is, in the first event that relates to that concept, say, of a person, I use a reference that is not actually referencing any existing event, but it's sort of like a dangling reference into the void, just by it claims that ID for that concept. And then when we have another event, it looks into the indices and finds, is there any event related to this concept that already sort of claimed the existence of that entity of a sort? Because you still employ some sort of domain language in your events, right? So person did that, et cetera, et cetera, et cetera. So you have to refer to those IDs as through the language that you define in your events, and by either referring to originating events, like the ones that bring things into existence, or by referencing sort of like free dangling ID by claiming that ID for the first time when you refer to a certain concept. That's how you define an ID. Does it answer your question? Awesome. Thanks. So getting back on track. So the interesting aspect of being able to build this kind of domain models in runtime is GraphQL. If you're not aware of GraphQL or don't know much about it, basically it is a query language and schema type of thing invented by Facebook that allows you to do a few interesting things. One of the things is you can send queries to your server, like from the front end, by using a sort of a non-rigid API. So in a traditional REST API, what you would have is, you would have a developer of a system define what you should get in response to what. Like basically, if I'm requesting a person, I'll get a dump of everything that's related to that person that I'm allowed to see. If I request a product, I'll get everything that that is there about that product that the developer of the system decided I should see. GraphQL allows you to ask the the backend, what exactly do you need? Like, do I need say an email of that person? Not really. I just need the name. So you just query the name. And it allows you to query a lot of things in one trip to the server. So you don't have to send one REST API call to retrieve the user and then see, well, there's a few more things associated with the user, and send another request to retrieve more data, more data, and more data, and while throwing out a lot of data that you're not interested in. So GraphQL allows you to compress that and ask exactly for what you need. And if you think about it, it actually maps onto this runtime domain model approach really well, because the way, for example, I implement these domain models is basically for every sort of field of the model, I have a method in just a Java class, nothing complicated. But if the front end is not asking for a certain field, I'm actually not calling that method. Therefore, I'm not actually querying for that data in the first place. It's not just filtering out the data from the query. I actually never query it because it just maps directly and it only queries things that I need. So the classes that I have, they basically don't contain, usually by default, they don't contain any data except for ID reference and reference to the repo so they know where to query the data from. But the rest is actually dynamically queried from the database. And yes, obviously you can add like caching to it, whatever is necessary for optimizing your sort of nicely looking software and something that actually works fast as well. So it maps really well and allows build those models very quickly and change them as you see them fit and not incur the penalty of querying everything and then having to filter through it and throw out things that you're not interested in. And there's another interesting aspect. It actually sort of came up last week when I was giving this talk in Vancouver. There was an interesting question in general about validations, how to do validations in this type of scenario. And the most sort of standard, simple way is, well, you have those commands coming in, that generate events. Well, just do a verification there. Like, is everything valid? If it is, generate the event, and we're done. If it's not, well, either generate nothing or generate some events to specify that something went wrong, if it's necessary for your idea. But a friend of mine actually pushed me on this and suggested another interesting way to look at it. What if we push the laziness? So basically, reacting to things as late as possible to the very end. So what if we actually try to do validations, not when we sort of receive the command and write down the events, but actually when we serve data? So obviously, it's not applicable everywhere, but it's kind of interesting. If you think about a very simple example of uniqueness, so you have a constraint that certain data has to be unique. All right. So one thing you can do, you can have sort of a lock, sort of in front of this whole process that locks on, the aggregate identifier, and basically does not allow more than one command, to happen at the same time. So we can ensure that the data that we're writing is actually unique. But obviously, it's problematic. You need to have this single point of entry. It slows everything down. It's not great for scalability either. You can't just have many servers handling those commands. You have to have a like serialized point. Everything has to go through it. It's not ideal in a lot of cases. So instead of that, what you can do, you can basically forget about validation until the very end. So if you think about the validation case, the uniqueness case. When you, for example, attempt to log a user in, your domain models would not just query for whether that user exists, with the right password. You would actually only care for the first person to do that. So that you can build a model that only searches in a certain way, saying like, I'm only interested in those who claim this, for example, email or nickname or something like this first, like with the smallest timestamp. And the rest, well, they're out of luck. And that means that even when you're doing the actual, say, registration process, instead of returning a simple person or user or account model to them, you can actually create a new model, because they're all just runtime things, that represents an encapsulation of the result of the operation, where it looks in the database and says, well, looks like you weren't the first one. So we offload that validation to the very end, and that allows us to record the command, to accept the commands and record the events while scaling this out. So we don't have to have this serialization point. And especially if we look at our data, if we see that most of the time there are actually no conflicts in terms of uniqueness, this means you're actually buying higher performance and better scalability for most of users, and only some of them, will sort of slow down a little bit on the read side, while allowing for the sort of write side to work, in parallel. So it's an interesting case But I think what's most important about it is that you have to have a sort of a slider, because there are cases when you do want to serialize and just want to go through one point, where you ensure that data is valid. But you can also move it to the other end and validate when it's necessary. Another, yep.
Imagine that you have this, and you have also a system that controls consistency of data. For example, I encounter as a reader of the system invalid data. I throw another event, and how do you handle, or where do you store the information that data are correct? That's the meeting point of the processes, isn't it? Mutex again?
Great question. So the question is, where do I store the information about whether the data is incorrect, right?
You were the first, obviously, but you don't know about anybody else in that.
Right. So from the system perspective, basically, if we do employ this read-side validation, right, we don't actually store it. We just compute it every time. And obviously, if it becomes expensive, well, you employ caching. That's where you store it. Basically, you have a cache that.
You are one of the readers. I'm the second one.
Mm-hmm.
Imagine that you have only one set of truth
Mm-hmm.
and a lot of readers, and the reader has separate data of each other.
Mm-hmm.
So every reader has to recompute the validation again.
Well, yeah, basically, like if you don't.
It doesn't aggregate, so you have to do that again.
Well, yeah, that's what I'm saying. Like the read side, it's like I was explaining, it is a piece of code, right? So basically it queries and does whatever is necessary to present that to the user. So yes, it will recompute it every time. What I'm trying to do with these type of models is basically to separate sort of the business logic from the optimization logic. I see those conflated often, and I think it's kind of harmful in the longer run because those are not the same problems. And many optimization problems are very well known, and if you separate that from the business, you implement your business logic to work first, and you learn what's actually happening. Maybe that's actually not a problem in terms of validation. Maybe it's fast enough and you just don't care anymore. If it's slow, you start thinking, okay, what optimization strategy can I employ in that case?
It kind of invalidating it upon arrival or on the source.
Yeah, well, there are many ways to do that. So
It might happen.
yeah, so in certain cases, you might employ a process like, for example, if something hits the invalidation, you can even record an invalidation or saying that this is invalid as another command event pair, signify that and write that down so that the sort of subsequent reruns of this code can benefit from that. So there are many ways. It really is dependent on the details of your situation. What is important for you? Is it important for you to write down the fact that we learned that this data is invalid? If it is, we'll just basically send the command to the repo again to signify that, and that would be your further optimization. So in many cases, you don't even need to use sort of side caches, like side caching technologies. You can just write this down as a sort of new event. You basically learned about something, right? That's an event. That's legitimate, and you can use that. And eventually, maybe, I don't know, computers get faster, right? The event is still there, but you don't care about it anymore. You might actually recompute it because, well, I just don't want to hit the disk anymore, just to read that event. So it's all about being able to go back and, and change the decisions that we have made before, and,
Yeah, it's kind of your laziness.
Yeah.
If you put optimization on the end.
Yeah, it's a lazy model, yeah. Yeah.
Question about that as well. So you were saying earlier about the idea that you kind of got this global kind of sea of facts, but different people are looking at it different ways. If kind of there's this implied kind of semantics where the user with the earliest timestamp with the email address is like the valid user, does that mean everyone has to know those semantics when they're looking? You know what I mean? Because like there's a risk if someone doesn't know that,
Right.
I have to only
Okay.
have to filter on the first user.
So the question is, like I was talking about the certain semantics where I say, well, the first user that has registered, with that email is the one to sort of, win because, well, he or she, was the first. And the question was, does it mean that sort of everybody else using that sort of sea of facts have to know those semantics? Well, my answer would be not really, because the semantics are sort of contextual to your model, like, or composition of models, right? This is how you choose to interpret the facts, right? If somebody is looking at patterns of attempts for registration, they see the model differently, right? For them, it's like, what are the patterns? Like, you know, we need to investigate what's happening. Why is it happening, right? Maybe there's just an error in the code that leads to this. You know, our programs are not perfect, right? So there's something that might have been happening. And for example, we were changing emails to some hard-coded email in certain cases. I mean, it's weird, but anyway, it could have happened, right? So by analyzing what we wrote down, we can actually see, oh, okay, you know, just our code, for example, in the command that generates those events wasn't correct. So we can actually, you know, figure it out, fix the code, you know, going forward. So I think that sort of, those semantics are only important within your context. So, and your code defines those semantics. So it's highly contextual, I would say. Okay? All right, so the next one. So there's a lot of people who say that, you know, do-it-yourself event sourcing is the way to go, because, you know, you might have sort of special requirements, or even, you know, an argument that I hear more is that, well, it's not that complicated. It's really just, you know, a left fold. You know, take an event, apply it to a database. How hard can that be? I don't think that's the case. If you start looking into querying data and building, you know, efficient indices and like, how do you manage this? It's just not practical. But what is even more important is that kind of knowledge. If you build that system, it's a great exercise, of course. But if you build that kind of system for every project individually, there's no knowledge transfer happening. So you can't really, you know, take what you've learned and come to another project and apply it again. You either have to redevelop it, or if they have their own version, you have to, you know, change your assumptions and relearn. So if we don't sort of push towards having, you know, some sort of even vague standards or, you know, vague definitions of what that is, we can't really interoperate. And if we build, you know, individual micro frameworks within our applications, that is not, you know, helping us to have really good ones, because we will have just very specialized small frameworks that are not reusable in any way. So what I did is, about a year ago, I started a project called Event Sourcing for Java. And for those interested, you can find it at eventsourcing.com. It's very easy to remember. This project is not very complex, really. It's taking, obviously, you know, the common definitions of what a command is. How does it work? You know, what an event is. How does it work? How do we know how to serialize data, how to read data? Basically, you know, the type system. And we put two more components. We have a journal to record everything, and we have indexing. And that's pretty much all of the sort of library/framework there. But the interesting thing that I found there, once I had this kind of minimal framework, I started working on a few applications, and I found two interesting cases. So one is, I started seeing very similar events spread across my domain, where I would have, say, person change, a name changed, and then product name changed. You know, this type of events that really are very similar, but yet I have like so many events, it's hard to manage. And I found that, well, what if I just drop the, you know, what I'm working on and just have a sort of a polymorphic reference, basically pointing, well, I'm working with that thing, whatever that thing is. And I'm just saying it's an event called name changed. Like, as long as there is a concept of what is a name, you know, what is a name change, we can actually apply it to anything, to a person, to a product, to, I don't know, any item that you have anywhere, you know, where the name applies. And the interesting thing that comes with it is that you can define sort of protocols saying a thing can be named as long as, you know, there are events changing the name of this thing, and that means we can actually share code that figures out the name, the price, whatever that is, you know, important for any kind of model without having to rewrite those queries again and again and again. We can sort of plug them into the model and reuse them as sort of shared like microlanguages or like tiny micro schemas that define certain traits of the models as you see them fit. Some people might not care about some of the protocols you use, and that's fine, because it's just an imaginary sort of extension to it. And when I started working with this shared microlanguages, I thought that there should be more than just the implementation of this principle, but what is important is actually writing this down. So basically saying, well, this is the type of event that we should have in this case, and here's the layout with data types, et cetera, et cetera, et cetera, and share it with the rest. So this is how the RFC effort came out of this. So basically just writing down, like, this is the thing. You don't have to look in the code. It's right in the text file here, just describing what it is, and let's try to figure out whether this works. Once this works, we can sort of nominate this RFC as a stable RFC and use it across projects. Meaning we can actually develop a library of events and then use it across projects for certain domains, instead of having incompatible pieces that do the same thing, but do it slightly differently. Just different names, slightly different types, slightly different fields. This would help actually to reuse the code, which is one of the goals of responsible software development. And a thing that came out of this is even more important, I think. I started writing down the RFCs for how the system actually should work. So I started by documenting what is it in there. So how does the repository work? How do we define the type system? How we serialize data? So all of those things, so that you can actually take those RFCs and actually re-implement the very same thing that will be compatible in any language. Because event sourcing for Java is for Java, so you can only use it on JVM. But if you want to use it in JavaScript, Ruby, whatever, you can actually do the very same thing without having to read the original source code, but read the specification instead. And the last small thing. So basically, with this RFC project and with this idea that others might want to develop other implementations and contribute in any other way, I wanted to find a way to welcome people more than people would normally do. And we're doing this by employing an idea that was discovered in a few projects. If you're aware of ZeroMQ, for example, they employ a process called C4. It's a collaborative code construction contract. And basically it boils down to a few very simple points. One is we merge pull requests as they come. Basically, there is no review process that has to happen upfront, like before the merge. Like, how many times have you submitted a pull request, sometimes even a trivial pull request, only to see people, nitpicking about indentation, variable names, or like do this and then squash that, and then I'll maybe merge your pull request, probably many times. But do you remember the moments when you send a pull request and within a few hours you just get merged? Like, what is the feeling that you have? It's just like, yay, right? Like, I got it in. Like, it's nice. I participated, right? So the idea here is just get it in. Merge it in like within hours or minutes if possible. And that doesn't mean we actually have to compromise on quality. Well, first of all, it's Git, right? We can revert everything. Again, it's kind of event sourcing model as well. We can reverse any decision. And the most interesting thing is if you do care about the problem that you see in a certain patch, enough to actually be really annoyed about it, well, your next step is basically to send another patch. If you don't have sort of enough of motivation to send a patch, then the problem wasn't really important, because you don't really care, enough to correct whatever that was. But it allows the project, to give people that initial first kick of getting in, and to incentivize them to contribute more. And what this leads to is, it actually leads to a real diversity, because it's not only a sort of superficial diversity, but it's about diversity of ideas that come into your project in form of the code. And it also prioritizes code now over consensus later. So we can actually ship something, something that works, and if it doesn't annoy anybody, that means it's good enough. With that in mind, I want you to do ideally all three things. So one is check out blog.eventsourcing.com. So I cover topics that I've been talking about today in more detail there. Pretty much, yeah, expanding on each one of them. Play with the food sourcing example. It's a small example of a food ordering application that's built using the framework. And obviously, if you like this topic, come to our Gitter chat room. I'll distribute the PDF of slides, so there will be a link. But it's basically just on gitter.im, event sourcing/event sourcing. Very simple. Yeah, that's pretty much it. If you have any questions, you still have time to ask, or you can talk to me anytime today or tomorrow. That's pretty much it.